So yeah, hi guys. This is another episode. This is another episode of the 3D and Scratch series. But this is a new. This is a very special episode. Instead, in this, we're going to add rotation to our spread to our cubes, to our cubes and tetrahedrons. So, well, we are going to really consider the tetrahedron though. So we're going to yeet this ass shape for generator. Okay, we need to remove this. Remove this. Remove the rock first. And boom. We haven't really considered the tetrahedron yet, though. I was experimenting before to get the coordinates of these done, and I haven't really done it for the tetrahedron yet. When I was recording. So maybe you can do the tetrahedron for me, and you can show me the coordinates, your coordinates down in the description, and I'll credit the first person who does it. And I'll credit the first person who does it in my next episode, and give him a shout out. So that uh, I I remember this is one of the more complex topics I'm talking about, but trust me, all the complex blocks we're going to add here are just going to have simple functions, have a simple function of existing, and how and what they contribute and what they and what they do to to make rotation possible is very simple. It's very simple actually. It's very simple actually. So on the outside it may look complex, but if you understand it, it's actually easy. It's actually easy actually. So without further ado, let's get started. So first though, you need to go watch episode two's scripts. But if you're new to this and haven't made anything, you should go to the episode one. Do episode one to get the scripts there. Then move on to episode two, and after you finish those, you can move on here. I'll put the link in the description. You can if you if you want if you if you need to. It's for convenience there. And before we add the rotation, we need to make some improvements. Well, first improvement you can see here is I've replaced the whole generate shape cube block. Well, in fact, we don't even need a shape variable as well. We're not even setting it anything. So we'll just set it the cube. Get out this tetrahedron and get an F. If you want to generate multiple shapes here, then you can just get an if else and check if shape equals your shape. In this case, for example, tetrahedron. Then you will set the code for the tetrahedron. Set the coordinates of the tetrahedron, which we will add very soon. Where's the go to XYZ block, you ask? Well, I've replaced that block with a draw line, with this draw line block, and instead of the labels, I just added inputs. So what do these inputs correspond? The X ones and Y ones, Z ones, basically the XYZs that have a one in it. Uh, that corresponds to its original to that point's original position, and the variables that have a 2 in it, and in this case the x2, y2, and z2, those are the coordinates that the point is going to go to to draw a line. Those lines combined together will make we'll make the cube after we after we add the rotation and stuff. Don't press the green flag yet, or you're going to get this thing. Well, we haven't added the rotation yet, so yeah, it currently looks like this. Well, it isn't. It may look bad, but after we polish it, it'll look like the cube back on episodes 1 and 2. Episodes 1 and 2. Okay, you just need to wait. You just need to wait. Okay, and you and not all things happen instantly. You know. Oh yeah, and the controls broadcast. This is now a broadcast block. I almost forgot to add that. My bad. I almost forgot to add that. My bad. Don't make the same mistake like me, okay? Don't make the same mistake of adding that like me, okay? Okay, so I'm going to give you some time copying all the improvements I've made, and then after that we're going to add the rotate. We're going to finally add rotation, and end this episode. Oh yeah, if you can hear some music in the background, yeah, that's my little sister doing YouTube, watching YouTube in the background. Please, please don't mind that. Don't mind that. Okay. I tried to ask her to turn down the volume and she didn't. It's her problem, not me. So after you've made this and this, you can pause the video to copy these. We can move on to this. These these are all run without screen refresh to make them fast, to make them fast, faster than your normal custom, your average custom block, without run without screen refresh, because well we want this to well well uh, trigger the code fast. So we want to generate the shape faster. Well, the go to X dogs are well the same for this. Well, but for this we just change the X ones, Y ones, and Z ones with X two with all the X twos, Y twos, and Z twos. We just switch them. We just switch them. And after you've done that, we can now find let let's now make some variables. I think some may be the wrong word to say, as we're going to have to make a lot of variables to check for the horizontal to check for the horizontal points where the where the where the points are going to rotate horizontally. Then the variable that checks that is for for when we want the points to rotate vertically. And what if we want to rotate the face of the cube 180 degrees? Yeah, we need some variables for those too. Yeah, so we're going to need two extra variables as we can rotate. Yes, we can rotate a shape's face two ways by rotating it clockwise and rotating it counterclockwise. Yeah, we can move we can rotate uh, that shape like two ways. So we're going to need two variables for that. So we're going to need two variables for that. So okay, let's make the variables. Now the first variable we'll call vertical point for when we want this variable is for the shape, is for when the shapes want to, it's for when the points want to want to rotate vertically. Then another will be horizontal point. It will be horizontal point for when the shapes want to rotate horizontally. Oh yeah, all the variables we're going to make, they're all going to be this part only. Yeah, for your information, I've already said that before, and it's important. Oh yeah, as they rotate, their z position is going to change. So we're going to need a variable to check. So we're going to need two variables to check. So we're going to need a variable to check, one variable to check the z position or z rotate. We're going to call this z rotate. This is a variable. That's the variables we're going to check our z position. Z position. That's going to decrease when we rotate down. Then it's going to increase when we move. When we rotate, like why this happens is, well, objects seem to get farther away as they move away from the camera, but get closer as they get closer to the camera. Sorry, I was drinking water there. I can't really speak that fast. Okay. Well, in the green fact though, but we aren't done. No, we also need to. Sorry, I accidentally pressed the green flag. What was I about to say? What was I about to say? Oh yeah, we're also going to need some variables to check the movement speed or move x for this sprite. Then move y. Do the same for the y position. So we'll also get move y. Then there's also the x and y positions of the points that are being rotated. So we're going to have to make three variables, that is ex, ey, and ez. Why do I call that? Well, the e stands for the entity or point, or in this case the entities are the points. Ex for this part only, ey, and ez. For your information, you're gonna delete shape variable. So the ex, ey, and ez will the e so yeah, the variables ex, ey, ez, then and where the z rotate vertical point, the z rotate, and the horizontal horizontal point, and the move x, move y, and move z. Do we even move z? Oh yeah, wait, yeah, I forgot move z. We need to add those two. We need to also check the sprite z position too. Z position 2. So we'll go. So we also need to. There's a moveset involved too. So in the green flag clicked, we're going to set those to 0. You should have about 9 variables in total that will be set to 0 at the green flag. Please check those to check if you have enough. If you have all the variables here, right? I've just took the check mark on these to show you which variables to set to 0 here. We're first going to start with the vertical point. Then of course the move X, move Y, and move Z. Then there's also the EX, the enter point X, EY, and point Z. Point Z. Now, well, we want our EZ to be 200, and this is our Z position. And as this is a Z position, then we want this to be like, we want the default to be close to the screen, or should I say player view, close to the player view as for default. And in the controls, we will set values. We will set the values to for when we want to rotate up or down, or we want to rotate the face of our cube. So let's set those. If you don't know what this trick is, maybe you should go back to episode 2. But to recap, when you place these key press blocks in one of these placeholders, in these operators, in one of 4 of these operators, they're going instead of saying true or false, they're going to turn into 1s or 0s. So the 1s mean that this is true, and 0 means it is false, which was the trick I used to make the code shorter and more easier to read. I learned that from Wisecrasher. Yeah, even a teacher has to learn from somebody. So yeah, we're going to set the vertical point to. So we're going to set the vertical point to. But there should be a change. Sorry. Oh yeah, I forgot one. It's just delete this entirely, and you can just see that for reference. Instead of set cam y, we can just change the variable cam y. Then the forward or backward can be cam z. Then left right be cam x. Then instead of sets are going to change, as we don't want our cube to instantly teleport to the position -1, which is like here, if I believe. if I believe we don't want our cube to be the right arrow keys, so we're going to choose something else like the we'll just set our vertical rotation to the F and H keys on our keyboard. Then for the horizontal point, then for the horizontal point of our axis, then for horizontal point we'll go to our T and G keys on our keyboard. Then for a Z rotation we'll choose then for a Z rotation, well, this is actually when we want to rotate counterclockwise. This is the variable that will look at that will be used to change or make the cube's face turn counterclockwise. So what do we want? So what I want to do with that? Oh, let's make this using the J and L keys. The J and L keys on the keyboard. I'm just using the position of the WASD keys and looking the keyboard for similar patterns, and I found out that the FHTG and JIKL keys are the only ones that follow the same pattern. The others look similar, but it's just that the top key doesn't. Very well. You don't really need to follow this pattern. You can set it to any key you want. You don't need to set the key. The key is the key press. Well, doesn't really need to be specific. It's your choice. It's your choice to which key you want to press to be able to rotate the shape. And for the move Z block, okay, I accidentally said move. I accidentally said move X. That shouldn't be the case. We'll just set this to the I and K keys. After you've done this, we're going to add an if condition. This is very specific, and I'll tell you why. We should do this after we place it down. Okay. So if get an or. Sorry, there should be an and, not an or. And then not. And a not. And a not. And a not, well, key. get a knot and duplicate the vertical and our horizontal point keys. These will be and and our and our move Z block. We're going to need those and put them here. Get an equals. Well, these if blocks are going to change the move X and move Y, the move X and move Y variables, which remember we created those earlier, and also the move Z block, which dude, we've already set up before. No, but this is a change. We want this to set after we set the after we will rotate it. So again, well, these, if you remember, both give out -1 or give out either ones or zeros. If key H is pressed, that means we're, for example, well, going to the right, then, well, yeah, this should. Well, never mind. We're not really focused with the key inputs here. We're just trying to test if this works or not. Then we'll fix the key inputs. If not, key press is equal to the absolute value of 1. Well, instead, you should my bad. It was you should actually put the absolute value inside here. So what's the absolute value? This absolute value block spits out only positive numbers. So if, for example, if I enter a negative number, say -1, it's going to say the +1 instead of -1. It only shoots out. It only outputs positive integers when you give out a negative integer, and that can be useful as the only positive and negative integer, as this one here can both be a positive and negative integer. So just take the absolute value of that and check for only one only. And check for only one condition only. Then in this, we're going to set our move X then this will be move Y. Remember, move Z is this one. The ones for the vertical point is this one, and ones for the horizontal point. Sorry, this is the vertical point. This is the horizontal point. So we'll set move X to its original move X. That is, in this case, -1. That is either plus or -1 multiplied with 0.9. And well, to make the movement smoother, we'll do the same for move Y and move Z. And get a move Z. Sorry, move Y. Now move Z. so like this if so these ifs make our movement of rotation feel more smoother instead of what more jagged and rough, and unlike in real life where the rotation is smooth, like when we move our eyes. We want to capture that realism in our projects too. Then for the final touches for this, we'll just set our ex that is our point x to the move x to actually register our movement. Do the same for ey, like this. Then we also want this to we also want to do the same for easy, but we can't do that normally. Instead, we need to get an if else, and we need to check that the sum of move z plus ez is greater than 65. Why do we want to do this? Well, because we don't want the cube to be looking too big, such that we're going inside the cube. We don't want to go inside the cube, so we need to set a limit to how far we can make it big. So the z position is, well, basically the depth and how big an object seems to look due to how close it is to the player camera. So move z plus ez. We'll set our limit to a great number would be 65 from what I've experimented. Then we'll set instead actually change ez by move ez. If it is greater than 65, then we'll set this to 66. This is our default limit. This is a maximum limit, but you can change this to make your number bigger, to make how much you can change the size of it bigger. Just don't make it too big. Just don't make it too big to the further you can, well, to the point you can't see it. Don't do that. Unless you want to unless you don't want to see our cube rotating, well then do it. Okay, don't do that. So okay, now we've defined our variables, and now we can change them. Now what do we do next? Well, we need to actually make them go to the coordinates to the coordinates when these variables are being increased. We need to address the value, then change their exposition depending on how much their x, y, and z positions, depending on how much of that variable is changed. For example, if the vertical point has changed by 2, then they need to rotate and change their x, y, and z by some function, which will make spoiler alert, that function is going to be a custom block with some very complicated math, quote unquote math. So in our draw line block, we're going to we'll make 3 new blocks. Rotate x. Okay, what was I doing? Then we'll get our x. Then we'll put our x, y, and z inputs here. We'll stick this block at the front. And we're actually going to make this drawn draw the stuff while simultaneously setting their x and y positions. For the second block though, we'll make rotate y for the y position, enter the x and y and z inputs here. Oh yeah, this rotate y will be dependent on rotate x. So, and for rotate z, well, it follows the same logic. It will depend on rotate z, which will depend on rotate x. Just like before, to enter the x, y, and z inputs here, make it run without screen refresh. I was just checking back there if we were running with screen refresh. So now we've made our blocks. Now let's add. So remember when I talked about that where it was going to evolve complex math? Yeah, this is where the complex math is going to be involved. This is where the complex math is going to be involved. Yeah. But first, we'll get rotate y. Oh yeah. Wait, I forgot. Remember we were supposed to make 3. We actually. I was sorry. I was blatantly lying. Sorry, it was my bad. We need to make just one last block. Okay, and point x, y, z. This will be dependent on the z input on our rotate z block, after we've calculated from these 3, it is going to send where the points are going to go into this, and this is where they're going to set the points, set the coordinates, and make it go there. So when this will get a point, then for rotate y, go to rotate z. Yeah. After we've done that, we need to set the value for these inputs. For that, we're going to get an x, subtract. Okay, it should be here, not there. X divide x, multiply, divide, subtracted, multiply, subtract, multiply to effect x times. Oh yeah, for these we need to also state the angle of where the point is. Since this is a 3D space, angles on points on 2 lines actually exists now. Depending on the position. So we're going to have to make a variable for that too. We'll call this angle theta. If you don't know how to spell theta, you can see the word from here, theta. Okay, got that? Do the same for all the rotate blocks. That includes rotate X, rotate Y, rotate Z. Yeah, this is going to be angle of where that point is. So times this block is this block the structure of this block is similar to the to this go to X block where this is Z, but instead of the you multiply with these variables, you multiply them by the sine and cosine of theta. Okay, this is new. What are these sine and cosine? So cos for short. So have you known do you know trigonometry before? Well, if you don't know, well, basically, trigonometry is a part of math that relates lines to angles. Yeah, it's kind of complicated at first, but it's kind it starts to get easy if you know if you if your teacher is good. I hope I'm good to you. I hope I'm good to you. Please do not get bored. Please do not get bored, okay? I know this video may be long, but life has to get complicated sometimes. And to achieve certain things. And this and making 3D shapes rotate in such a programming language like this is one of them. And all of that work is going to be paid off after this episode is finished. But don't worry, a more difficult if you like that one, a more difficult one is going to come next episode. Stick around for that, as that's gonna be a way more bumpy ride than this. So after that humongous value is finished, then we're just going to set the y input to vote this y. Then for the z, well, the z is the same thing as the column or x instead just we just will replace swap the values just like that. And for our angle of theta, we'll just set this to the horizontal point. Yeah, that variable we just set. It's not going to come to play in the angle of where the line is. Of the line is. Then in rotate y, I need to drink some water real quick. Yeah, in the row. So in this rotate z. We're also going to repeat what we did. We're just going to copy that. But we're going to make some changes. Instead of the sine, we'll get the cosine and the sine. And you could probably search about what is trigonometry on YouTube. That's a if this is a whole nother if you want to learn uh, trigonometry, that's a whole nother video about a grade about a grade 12 about a what's that, grade 8. Oh yeah, grade 8. Yeah, you learn, yeah, grade 8 secondary too. Yeah, but back on that later. Instead of the z, this is actually the y. This is actually the y value. Then the y, well, we don't put y, we just do this. We just do this. We just do this and swap the values. Swap the values and change the sign to the cosine. Then for the z, then for the z value, you can just, well, do the z you made. Sorry, my bad. This is not. I was actually bluffing. This is actually z, not y. It's actually z, not y. And this is not a plus, minus. This is not actually a minus. That's a plus. This is a plus. Then fine. Then finally, to put the nail in the coffin, we need to look at rotate z. This is the same thing. This is the basically the same thing as well. And second note, this shouldn't be. This is actually x, y, yeah. And z. And for rotate y, this is the z rotate. And if you remember the zero, if you remember the z rotate is the oh yeah, if you want to change the cube, if you want to change the cube's face, the clockwise or counterclockwise. Check it out. This should be minus, not plus. I saw. And now this is not. See, this is y. Then for y. This is This let is plus. Replace the swap the sign with cosine. Sorry, never mind. Don't do that. Don't do that. I remember it makes an error. And this is the z. This is z. This is z, and let's check if we got that correct. Let's check if we got everything correct. There should be this. You know what? Just double check by while doing this. By just while doing this, yeah. Yeah, this is rotate z. Yeah, this is rotate z. Just check by while doing this. We just want to set the value. Well, we just copied all that code from this, and this was going to copy that code, replace this detail with detail. Well, for your information, this detail and this detail are not the same. They come from different blocks. Just do the Control Z to put them back and not distinguish them. And distinguish them. No, you don't. You don't want to do that. That will make an error that you probably can't fix. Also change the theta too. Okay, the rotate Z is done. Do the same for rotate X. Rotate X. Do the same for rotate X. Aha, the problem. There should be the sine, cos. There should be the sine and there should be the cos. Y is y, z, cos of theta plus sine of theta. Okay, then. That's almost check. That's almost checked. Then for rotate Y, check that. X10. This is where we should replace. y cos of theta, and we'll just replace them with this. Please don't be bored out, okay? I know. And that's about it. Okay, so, well, you may think, oh, this is so complex, but no. These actually said these actually set the coordinates x. This one sets the y, and this sets the z position for the points, and then for the final z block, this will send the data collected from the points made from x and y, then to this, which will set the point, which will actually make the points go to the x, y, and z positions on this stage. And speaking of point x, y, and z, we'll add those. So in this, we're going to make two new variables. Sx will sum x. We'll call this xx for short. Do the same for y. Do the same for y too. Sx, xy, sum x, sum y. Then in sum x, get a plus. We get the plus for both sides. We'll do the x. We'll do the x for x part first. This the ey is actually the same. We'll add ex. We'll add ex here. And then in here, then in a new denominator, we'll add ez plus z, or z plus ez. That is also equal to that. Then this will get a multiply. Add x plus ex. That is our point x with times the ez, or our or the z position of our. Then we'll do the same for ey. Then we'll do the same for ey. It's just that we'll just replace the ex's with ey's. Do that. Boom. Oh, okay. My bad. Then instead of ex here, we'll do ey. Just like I said before. So after we set sx and xy, what do we do on both of those? Well, we need to actually set the rotate x. So yeah, in this we'll set the values of the first, then the values of the second. Then in the theta, then in our angle, of that point, we'll just put the vertical point. Then we'll just put the vertical point. Then we'll. So now what do we do with the SX and XY variables? Well, actually, we're going to have to remake all the points. Remake all the points that actually calculate to the, because, well, duh. Although we'll keep the FOV the same. We'll keep the FOV variable the same. Keep the FOV variable the same, okay? Then in here, for a new function, we're going to add our camx plus our sx. That is the sum. That's the sum x. Divide by our 0.05 times our field of view. Plus our camz. This will be our new function. This function will also allow us to rotate our cubes while moving them. We'll now do the same for cam y. Instead, we'll just change the x's to y's. So cam x's become cam y's. The sx becomes sy's. The FOV stays the same, and so is the camz variable. This is also gone too. Okay, wait, there seems to be a problem that the cube, what we're generating right now is a small dot. What we have generated is like a small dot, and that seemed to have made it smaller. Wait. this. Yeah. There's some technical problem that I'm probably gonna have to fix. Oh wait, I don't. Oh wait, I don't know how to speed this up. Yeah. Feel free to watch me feel dumbfounded as I don't really know. Yeah, I. But wait. But wait, don't feel sad. Don't feel sad that I failed. I have a save file while I was making this, and this didn't have the and this has the it was working before, and I just wanted to tell you that. So yeah, this is the save file I made. Yeah, I just well made. I made this by myself. Okay, it's just that I can't really explain things very well. Which is probably I was trying to remake it out of my head, and I probably forgotten some of the script. Probably forgotten some of the scripts. Okay. But before you drop any hate comments below, and I'm surprised if you don't really drop any hate comments below. Please don't. Please don't. Okay. But in the end, if you do spot the problems, you're going to end up in a cube that we can both move and spin. That we can spin in all directions. You know what? I'll just let you just copy the code, okay? That code I made was a mistake, but hey, at least we tried, and that our participation was good. So in the end, it failed. But at least you get do have a good laugh though. Now copy now I'll just let you copy this. Oh yeah, all the variables given are I'll let you copy this part. Pause the video if you like. Yeah, all the custom blocks are on the screen refresh, and all the variables are well. Oh yeah, all the variables are are for this part only. So yeah, and I hope you have a good day and bye bye.